What do you picture when you hear the word monster? Is it a towering beast from ancient myths, a creature with too many teeth and eyes, lurking just beyond the edges of our known world? For centuries, our maps were filled with them. Here be dragons, we wrote, drawing serpents and krakens in the vast, empty spaces of the ocean. We told stories of leviathans that could swallow ships whole, and colossal squids that dragged sailors to a watery grave. These were the nightmares born from our fear of the unknown, the whispers we shared around flickering firelight about the secrets hidden beneath the waves. But then, something incredible happened. We explored. We sent submersibles into the crushing dark, cameras into the abyssal plains, and we discovered that the truth was far, far stranger than our fiction. The kraken of legend? We found the giant squid, a very real creature of the deep with eyes the size of dinner plates and tentacles that could wrestle with sperm whales. The sea serpents of old tales? Perhaps they were exaggerated sightings of the oarfish, a silver, ribbon-like fish that can grow up to 11 meters long, a living piece of metallic tinsel drifting through the gloom. The ocean, it turned out, wasn't empty. It was just waiting to show us its real monsters. And these real-life creatures defy imagination in ways no myth ever could. Take a journey with me, down, down, into the midnight zone, where sunlight has never reached. Here, we find a creature whose scientific name literally translates to the vampire squid from hell. Despite its terrifying name, Vampirotuthis infernalis is small, about the size of a football. It drifts through the perpetual night, a ghostly shade of velvety black, its 8 arms connected by a fleshy cloak, like a vampire's cape. When threatened, it doesn't squirt ink. It pulls this web of skin over its entire body, turning itself inside out and revealing rows of fleshy, harmless spines. It's a phantom that cloaks itself in darkness, a living piece of gothic horror from a world without light. Go deeper still, and the residents of this alien world only become more bizarre. Imagine you're in a submersible, peering out the viewport into the inky blackness. Suddenly, a pair of glowing green orbs float past, seemingly suspended in nothing. As your lights catch the creature, you see something that makes no sense. The orbs are eyes, but they aren't on the outside of its head. You are looking through the creature's skull, which is a completely transparent, fluid-filled dome. This is the barrel eye fish. Its eyes are housed internally, like twin emeralds, able to rotate and look straight up through its own forehead, scanning the faint silhouettes of prey far above. It is a living observatory, a biological marvel that breaks all the rules of anatomy we thought we knew. But perhaps the most alien concept the deep sea has to offer isn't a single creature, but a multitude pretending to be one. You might see what looks like a single, impossibly long, glowing string of lights, sometimes stretching for 40 meters or more, the length of a blue whale. Is it one animal? No. This is a siphonophore, and it is not a he or a she, but a they. It's a floating, predatory colony made of thousands of individual, specialized clones, all physically connected and working together. Some are for propulsion, others for digestion, some for catching prey with their stinging tentacles, and others are just for reproduction. It's a city, not a citizen. A fleet, not a single ship. A superorganism that blurs the very line of what it means to be an individual. A vampire from hell, a fish with a see-through head, a floating colonial armada. These aren't monsters from a science fiction movie. They are our neighbors on planet Earth. They are the stunning, terrifying, and beautiful result of millions of years of evolution in the most extreme environment imaginable. For a long time, we thought we had found the peak of nature's weirdness, that we had cataloged the strangest forms life could take. We thought the age of discovering new monsters was coming to an end. But what if it's not? What if the age of monsters is just beginning? We have spent the last century telling stories about creatures born from radiation, from chemical spills, from humanity's mistakes. These were cautionary tales, science fiction designed to warn us. But as our world changes at an unprecedented pace, as the oceans warm and their chemistry shifts, we have to ask a terrifying new question. What if those cautionary tales are about to become field guides? What if we are, right now, accidentally writing the recipe for a new generation of monsters? The deep sea has always been a cradle of strange life, but it was a stable one. The rules of pressure, temperature, and darkness were constant for eons. Now, we've broken that stability. We are injecting new ingredients into this ancient evolutionary soup. We are changing the rules of the game for every living thing on this planet. But nowhere is that change more profound than in the dark, mysterious world below. The forces we have unleashed are powerful enough to twist and reshape the very fabric of life. To understand what might come, to see the outlines of the creatures that could be born from this chaos, we first need to look at these powerful forces. We need to explore the crucible of change that is the modern ocean. The engine of evolution, which for millions of years has been humming along, is now kicking into overdrive. And it's being fueled by us. The story of tomorrow's monsters is not one of myth or legend. It's a story of science, of survival, and of consequences. Every system has a tipping point. For millions of years, the ocean has been the great stabilizer of our planet. It absorbs heat, it drives weather patterns, it breathes in carbon dioxide, and it maintains a delicate, life-sustaining chemical balance. It is a system so vast and so ancient that we came to see it as immutable, an eternal force that could absorb any punishment we threw at it. We were wrong. We have pushed this system to its breaking point, and now we are beginning to see the cracks form. The crucible of change is heating up, and it is forging a new, alien world in the waters that cover 70% of our planet. The first agent of this change is heat. Our planet has a fever, and the ocean has absorbed over 90% of the excess warmth trapped by greenhouse gases. This isn't just like turning up the thermostat by a few degrees. This colossal injection of energy is rewiring the ocean's circulatory system. Currents that have flowed for millennia are slowing down, shifting, or stopping altogether. This chaos scrambles the migrations of countless species, turning their ancestral routes into dead ends. For cold-blooded marine life, a warmer world is a faster world. Their metabolism speeds up, they need more food, more oxygen, and they live shorter, more frantic lives. The entire pace of life and death in the sea is accelerating. But the carbon dioxide we pump into the atmosphere does more than just trap heat. A huge portion of it dissolves directly into the sea, triggering a dangerous chemical reaction. When CO2 meets H2O, it forms carbonic acid. Slowly but surely, this is making the ocean more acidic. Think of it as a slow-motion osteoporosis of the sea. This acid aggressively corrodes calcium carbonate, the very substance that millions of species use to build their homes and their bodies. Coral reefs, the vibrant cities of the sea, begin to bleach and dissolve, crumbling into ghostly white graveyards. The shells of clams, oysters, and sea snails become thinner, more brittle. Even the microscopic plankton at the very base of the food chain, tiny organisms with delicate, intricate shells, are starting to fall apart. What happens when the foundation of the entire marine food web begins to dissolve? Perhaps the most terrifying change, however, is the one we can't see. It's the simple act of breathing. As the ocean warms, it loses its ability to hold dissolved oxygen. Much like a can of warm soda goes flat faster than a cold one. At the same time, nutrient pollution from our farms and cities runs into the sea, triggering enormous blooms of algae. When these massive green tides die, they sink and decompose, a process that consumes vast amounts of oxygen. This one-two punch is creating enormous underwater deserts, not of sand, but of suffocation. They're called oxygen minimum zones, or more simply, dead zones. These are not small puddles. We are talking about vast regions of the ocean, some the size of entire countries, where the oxygen levels have fallen so low that most complex life cannot survive. Fish, crabs, and squid that swim into these zones either flee or they asphyxiate. These are ghostly, silent expanses where the normal rules of the ocean no longer apply. They are spreading, growing in size and number, like a cancer within the world's circulatory system. From the perspective of most marine life, these zones are wastelands, an expanding aquatic hell. And here is where the story takes a turn. Here is where the horror truly begins. Because where there is death, there is also opportunity. Nature abhors a vacuum, and these dead zones, these acidic seas, these feverish waters, they are a vacuum. They represent a new, empty frontier. Life has a remarkable, relentless tendency to adapt and survive. It has conquered volcanic vents, toxic springs, and the crushing pressure of the abyss. Why would this be any different? These extreme conditions are an evolutionary pressure cooker, a laboratory for creating something entirely new. This isn't just destruction. It's a selective event on a planetary scale. We are filtering out the life that thrived in the old, stable ocean, and we are creating the perfect conditions for something else to rise and take its place. The question is no longer if life will adapt, but what it will become when it does. The species that can tolerate low oxygen, that can weaponize the new chemistry of the sea, or that can find a way to thrive in the heat, will be the new kings of the ocean. For the life that can adapt, these new, toxic environments aren't a wasteland. They're a blank canvas, a new world to conquer. So, what kind of life could thrive in a warmer, darker, more acidic ocean? What kind of creature sees a dead zone not as a graveyard, but as a sanctuary? The answers may seem like fiction now, but they are rooted in the very real, very powerful forces we have just explored. The blueprints for these future beings are being drawn today, in the silent, suffocating depths and the acidifying shallows. Let's start with a creature that could turn one of the ocean's most beautiful and ancient phenomena into a terrifying new weapon. In the deepest, darkest parts of our ocean, there is a language spoken not with sound, but with light. This is bioluminescence, one of nature's most enchanting and widespread phenomena. You've seen it in the ghostly blue fire that can trace the edge of a breaking wave, a spectacle caused by billions of microscopic dinoflagellates. You've seen it in the gentle, rhythmic blinking of fireflies on a summer night. In the deep sea, it is the default mode of communication. From the dangling lure of the anglerfish to the shimmering clouds of ink shot by deep-sea squid, light is used to attract mates, to startle predators, and to find prey. For eons, this has been a world of solitary sparks and simple signals. But what happens when these simple signals learn to speak in sentences? What happens when they learn to lie? Imagine a species of small squid, perhaps no bigger than your hand. Alone, it is insignificant, a minor player in the grand food chain of the deep. It has the same biological toolkit as many of its relatives. Chromatophores in its skin to change color, a jet for propulsion, and of course photophores, the tiny organs that allow it to produce its own light. In the old ocean, it survived by being quick and staying hidden. But in the new, warmer, and more competitive ocean we've created, being small and alone is a death sentence. To survive, it needed a new edge. It didn't evolve bigger teeth or stronger venom. It evolved something far more terrifying: cooperation. This is where the phantom swarm, or as we might call it, the Abyssal Puppeteer, is born. It begins with one, then a dozen, then thousands of these small squid, drawn together in the suffocating darkness of the expanding dead zones, places where larger, more oxygen-hungry predators can no longer hunt. Here, in this new, empty territory, they developed a collective consciousness. Using their photophores with a precision that borders on telepathy, they learn to flash in perfect, synchronized unison. The swarm ceases to be a group of individuals and becomes something else entirely. It becomes a single, living screen, a biological display capable of painting pictures in the dark. And what pictures does it paint? Nightmares. Imagine a school of lanternfish, drifting peacefully. Suddenly, in the abyss below them, a shape begins to form. It is a vast, luminous outline of a predator, something that looks horrifyingly like an ancient plesiosaur, a long-extinct marine reptile. The shimmering shape, perhaps 20 meters long, charges upwards. Panic rips through the school of fish. Their instincts scream at them to flee, and they scatter in terror. But their flight is not random. The phantom predator is a lie, a ghost made of light, but its movements are meticulously choreographed. The swarm subtly shifts the intensity and position of its lights, creating invisible channels and walls of perceived threat. The fish are not just being scared. They are being herded. They are puppets on an invisible string, guided by their own primal fear. They flee from the light ghost directly into a carefully prepared ambush. In the darkness, away from the main display, other members of the swarm are waiting silently, their lights off. The panicked fish swim right into a net of waiting tentacles. The hunt is brutally efficient, a combination of sophisticated psychological warfare and a perfectly executed trap. The horror here is not of being eaten, but of being so completely and intelligently outmaneuvered. It's the chilling realization that your own mind is being used as a weapon against you. The swarm's abilities wouldn't be limited to hunting. They would be the ultimate defense. If a real predator, like a deep-diving shark, were to approach, the swarm could conjure a phantom even larger and more terrifying than the attacker, a colossal glowing squid or a monstrous whale, scaring it away. They could even become masters of mimicry. By precisely replicating the bioluminescent mating patterns of other species, they could lure curious individuals to their doom. The Abyssal Puppeteer doesn't play by the old rules of the food chain. It rewrites them. It is a testament to the idea that intelligence doesn't require a single, large brain. It can be emergent, a ghost in the machine of 1,000 tiny minds working as one. Is this plausible? Consider the real world. Quorum sensing allows bacteria to coordinate their behavior once they reach a critical mass, acting as a single multicellular organism. The complex, synchronized flashing of firefly colonies are a real-life light show. The Humboldt squid, a known relative, is famous for its aggressive, coordinated pack-hunting behavior. The ingredients for the Abyssal Puppeteer are already here. Evolution would simply need to stir them together in the right way under the right pressures. The pressure of a new, hostile ocean we are creating. The emergence of such a creature would represent a profound shift in the nature of deep-sea life. It is intelligence born from desperation, a collective mind formed in the dark. It is a beautiful, hypnotic, and utterly terrifying possibility. But what if the very pollution we are pumping into the ocean, the physical trash we discard, becomes more than just a backdrop for these new dramas? What if it becomes a building block for life itself? The next creature doesn't just survive our waste. It becomes it. We have a strange relationship with our garbage. We put it in a bin, and it magically disappears, taken away to some unseen away place. But there is no away. Every plastic bottle, every broken electronic, every discarded wrapper ends up somewhere. A significant portion finds its way into our oceans, where it embarks on a journey that will last for centuries. On remote beaches, geologists have already identified a new kind of rock, a fusion of melted plastic, sand, volcanic rock, and shells. They call it plastiglomerate. It is the fossil of our time, a permanent scar on the planet's geology. We have introduced a new, immortal material into the web of life, and nature is beginning to respond. For most of ocean life, this plastic legacy is a death sentence. We've all seen the heartbreaking images. A sea turtle tangled in plastic rings, a whale's stomach full of plastic bags, a seabird starved to death because it mistook colorful bottle caps for food. Plastic is a physical threat, a choking hazard, and a chemical poison. It leaches toxins into the water and into the bodies of the animals that accidentally ingest it. For decades, the story of plastic in the ocean has been one of destruction. But evolution works in strange ways. In a world saturated with a new resource, even a toxic one, the organism that can find a way to use it doesn't just survive. It gains an extraordinary advantage. Let's travel to a place where this advantage would matter most. A polluted estuary near a major city, or a coastal dead zone where industrial runoff and plastic waste accumulate on the seafloor. This is a graveyard of our making, a chemical soup thick with humanity's refuse. And here we find a new form of life crawling through the muck. It's a large scavenger, something like a crab or a marine hermit. We can call it the Shard-Shelled Scavenger. From a distance, it shimmers with an unnatural, broken light. As it gets closer, the true horror of its existence becomes clear. Its shell isn't a uniform, calcium carbonate structure grown by the creature itself. It's a jagged, grotesque mosaic. It is a living plastiglomerate. This creature's evolution began in its gut. Through generations of exposure, a unique microbiome of bacteria evolved, capable of handling the endless tide of microplastics. They can't fully digest the polymers, but they can strip them of their most toxic coatings and break them down into inert, hardened fragments. The scavenger's biology has rewired itself to co-opt this process. Instead of excreting the plastic, it diverts these fragments to its mantle. There, it secretes a biological epoxy, mixing the plastic shards with heavy metals filtered from the water and a small amount of its own biomineral secretions. It isn't growing a shell. It is assembling one piece by jagged piece. The result is a walking monument to our consumption. Its carapace is a chaotic collage of our world. The murky green of a soda bottle, the sharp white of a yogurt container, the metallic sheen of a chip bag. Shards of glass might be embedded near its joints, and threads of synthetic fishing line could be woven through the entire structure like reinforcing steel. The shell would be incredibly durable, far tougher than natural crab shell, and razor sharp. It would be a fortress, making the scavenger nearly invulnerable to predators like octopuses or large fish, whose teeth and beaks would break against the unnatural armor. The horror of this creature is immediate and visceral. It is a monster we have literally built from our own trash. Its behavior would be simple and relentless. A slow-moving, heavily armored tank, it would crawl across the polluted seabed, using reinforced claws to crush and consume anything it can find. It is the ultimate janitor of the Anthropocene. But its impact goes beyond just cleaning up. By incorporating plastic and heavy metals into its body, it is locking them away, removing them from the local environment. It is, in its own horrifying way, a solution. An ecosystem that creates a shard-shelled scavenger is an ecosystem that is attempting to heal itself, using the only tools it has available. It's an immune response from the planet, and it looks like a monster. Does this sound too far-fetched? Look at the decorator crabs of today's oceans, which painstakingly cover themselves with sponges, anemones, and debris for camouflage. Look at the caddisflea larvae in freshwater streams, which build intricate protective cases for themselves out of sand grains, pebbles, and twigs. Nature has a long history of using the environment as a toolbox. Scientists have also recently discovered bacteria in recycling plants that have evolved enzymes to eat certain types of plastic. The geode crab is not a leap into pure fantasy. It is the next logical, terrifying step in a world that is becoming more and more artificial. These creatures, the phantom swarm and the shard-shelled scavenger, are terrifying. But for all their strangeness, they are still individuals. They follow the ancient rules of survival. Eat, avoid being eaten, and reproduce. They are still playing by a rulebook we can recognize. But what happens when the very concept of the individual breaks down? What happens when life, facing a world so toxic and empty, decides that individuality itself is a weakness? What happens when life abandons the vessel of a single body and becomes something vast, ancient, and utterly alien? We have a deep, instinctual need to categorize the living world. We see an individual, a fish, a bird, a person. We see a body with a head, a tail, a beginning, and an end. The creatures we've imagined so far, the phantom swarm and the shard-shelled scavenger, still fit this mold. The swarm is a collection of individuals acting as one, and the scavenger is a single, armored body. They are terrifying, but they are knowable. They play a game of survival that, on some level, we can still understand. But what happens when life decides the game itself is obsolete? What happens when, in the face of a world turning toxic, the very concept of an individual body becomes a liability? Return with me to the dead zones. These vast, suffocating regions are the fastest-growing biomes on Earth. They are silent, dark, and almost entirely empty of the life we know. To a fish, they are a wall of death. To us, they look like a void. But to a different kind of life, a kind that breathes sulfur instead of oxygen, this void is not empty at all. It is a promised land. It is a vast, calm, nutrient-rich soup, filled with the decaying matter of the world above and the chemical runoff of our civilization. It is the perfect primordial ooze for a new genesis, a genesis that could abandon the blueprint of the individual altogether. Let us call it the Sentient Anoxic Bloom. But the name is a deception because it is not a bloom in the way an algal bloom is. It is not a collection of separate organisms. It is one single, continuous living entity. Imagine a biofilm, a slimy layer of bacteria, but instead of coating a rock, it has become the water itself. A colossal, gelatinous web of organic matter and microbial life, stretching for kilometers across the ocean floor and rising hundreds of meters up into the water column. It has no skin, no bones, no organs. It has no center. If you were to sail a submarine through it, you wouldn't see a monster. You would simply notice the water had become thick, oily, and strangely coherent. How could such a thing be alive? How could it think? It wouldn't have a brain or a nervous system. Its consciousness would be purely chemical. Picture a network of fungal mycelium, a hidden web beneath the forest floor that can stretch for miles, passing nutrients and information from tree to tree. The bloom would be like that, but its network would be its entire substance. A change in pressure on one side would trigger a slow, cascading chemical reaction that ripples across its entire body. The introduction of a new toxin would be tasted and remembered as its chemistry shifts to metabolize it. It is a single, thinking ocean current, a distributed mind, slow, deliberate, and utterly alien. This creature would not hunt. Hunting is a frantic, energy-intensive activity for individuals who need to find their next meal. The bloom has no next meal. It simply is. It exists in a permanent state of consumption. Anything that dies and sinks from the sunlit world above becomes its food. The endless rain of marine snow, the carcasses of whales, the shoals of fish that accidentally wander into the anoxic water and suffocate. They are all gently, passively enveloped and absorbed. It would be the most efficient scavenger imaginable, a planetary-scale digestive system. There would be no violence, no chase. Just a slow, silent, and absolute process of incorporation. The horror of the sentient anoxic bloom is not in its teeth or its claws, for it has none. The horror is in its scale and its alien indifference. You cannot reason with it, you cannot fight it, you cannot even properly identify it as an antagonist. It is a fundamental state of its environment. For this creature, our world of individual striving, of frantic motion and separate consciousness, would seem like a brief, chaotic frenzy on the surface of its tranquil home. It operates on a timescale of centuries, its thoughts taking hours or days to cross its body. It is as close to a geological process as a living thing can get. A slow, quiet, thinking ocean. Is such a thing even remotely possible? We see glimmers of it everywhere. Slime molds, single-celled organisms, can merge to form a larger entity that can solve mazes to find food, demonstrating collective problem-solving without a brain. Biofilms of bacteria already create vast, coordinated structures. The key is chemosynthesis, life that feeds on chemicals, not light or other life. Life in the dead zones would be forced to evolve this way. The bloom is merely the ultimate conclusion of these already existing biological principles, supercharged by a new, globally available habitat that we created. Is such a thing possible? Perhaps. The laws of biology are more flexible than we can imagine. But the existence of this creature, this vast and silent mind born from our waste, is not the truly scary part. The truly terrifying part is understanding why it could exist, and what its presence would mean for the world that remains. It is a symptom of a planet that is sick, and the nature of that sickness reveals a truth more horrifying than any single monster. We have walked to the edge of imagination. We've journeyed through a future ocean and witnessed the birth of impossible life. We saw the Abyssal Puppeteers, a swarm of minds painting with light to herd their prey. We met the Shard-Shelled Scavenger, a creature armored in our own plastic refuse, a walking tombstone for our throwaway culture. And we contemplated the Sentient Anoxic Bloom, a consciousness the size of a sea, a slow, thinking ocean born from suffocating waters. These are the monsters of tomorrow. They are spectacular, they are terrifying, and they are not the real horror of this story. For all their strangeness, these creatures are not evil. In the grand, amoral theater of evolution, there is no good or evil. There is only what works and what doesn't. There is only adaptation or extinction. The monsters we've imagined would not be aberrations or mistakes. They would be brilliant successes. They would be the logical, inevitable survivors of the world we are creating. They are nature's answer to a question we have asked with our carbon emissions, our chemical runoff, and our plastic waste. The question is, what kind of life can survive this? The real monster is not the creature that adapts to the poison. The real monster is the poison itself. It's the silent, creeping rise in temperature that boils life in its own home. It's the invisible chemistry of acidification that dissolves the very bones of the ocean. It's the suffocating blanket of the dead zones, expanding like a bruise across the face of the planet. These are the true antagonists of our age. We have become a geological force, a mindless, planet-altering entity more powerful and more destructive than any kraken or leviathan ever dreamed of. Think of it this way. The ocean is a mirror. For most of human history, when we looked into it, we saw our own fears of the unknown reflected back at us in the form of mythical beasts. But now, when we look into the future ocean, the reflection is far more literal and far more damning. The Shard-Shelled Scavenger is not just a monster. It is a reflection of our consumerism. The Sentient Anoxic Bloom is not just an alien intelligence. It is a reflection of our carelessness. These creatures are our legacy, shaped from the ruins we leave behind. They are the children of the Anthropocene. This isn't a distant, abstract future. The changes are happening now. As we speak, coral reefs, those vibrant, bustling metropolises of the sea, are turning into silent, white boneyards. As we speak, oyster farms are struggling as their larvae find the water too acidic to form their first shells. As we speak, fishermen are hauling up empty nets from waters they once thought were inexhaustible, their livelihoods vanishing into the growing dead zones. We don't need to imagine speculative creatures to see the horror. We just need to look. So what do we do with this knowledge? Fear is a powerful instinct, but it can also be a paralyzing one. To be afraid of the phantom swarm is to miss the point entirely. The point is not to fear the dark, but to question why it is spreading. The creatures of this new world, real or imagined, are not a threat to us. They are a warning. They are a message from the deep, written in the language of survival. They are the symptoms of a planetary fever, and we are the cause of the infection. We are at a unique and terrifying crossroads in history. We are the first species to become consciously aware of its own role as a mass extinction event. We are the authors of this story. For a long time, we have told tales about humanity's heroic battle against the monsters. But what if we are the monsters? Not because we are evil, but because we are powerful and careless, and have forgotten that our world is a closed system. The waste we create doesn't disappear. It becomes the foundation for the next world. The story of life on Earth has always been one of change and adaptation. The world has been a hothouse before, and it has been an icehouse. Life has always found a way. But it has never, in 3.5 billion years, had to adapt to a change this rapid, this violent, this thoroughly artificial. The monsters of tomorrow's oceans won't be evil. They'll just be survivors. They will be the life that is perfectly, horribly adapted to the world we are building. So the next time you look out at the ocean, don't wonder what monsters are hiding in the deep. Ask yourself, what monsters are we creating right now?